He is very smart and very handsome, and he's in the academia. He comes from Aragon, a very, well, one of the best places in this country. All right, Ricardo, please introduce yourself. You have the floor. Okay, much better now. Good morning, everyone. I will be telling you about electronic ID. So this So I am the guy on the right, as you can easily see. At this point in time, I work as an assistant professor at the University Defense Center, and my main research lines are those on the screen. And as I said, this work has been put together by Victor Sanchez. Unfortunately, he cannot be with us today. He studied informatics engineering at the University of Zaragoza. Part of his work was also part of his dissertation. So there is a link there for you to access to the PDF file. We are working on the article and it's pending review. And now he works at the security company. So this is the agenda of my presentation. Brief introduction to give you some context, some background about, well, our Spanish identity cards, a bit of NFC, and how communication is established with the electronic identity cards, and then the testing that we did in that regard. First of all, what is identity theft? Identity theft has been defined as the theft of any personal information that would allow me to identify a third party. For instance, the name of the person, the date of birth, social security number, etc. Unfortunately, this is an increasing problem in Spain. When I was preparing this presentation, I found a URL telling us about 117 cases reported in Spain in 2014. This is a crime according to the Spanish criminal law. It is established in two articles, one of them being Article 401 on identity fraud. And this is I just did a cut and paste of what has been published by our ministry. And on practice, as far as I know, identity theft is considered, it's only applicable when marital status is stolen. And then also Article 196 on discovery and revelation of secrets. Question: who can steal our identity? Any criminal, terrorists, crime rings? And the most interesting question is, what for? Well, they will steal our identity for us to commit fraud or any other felonies. There are 4.5 million cases of fraud cases resulting from theft identity in Spain. The average fraud is around 8,000 euros. I don't know whether you have ever thought about this. What is the minimum information required, for instance, to subscribe to a telephone line or to hire an internet service? Especially if we do that electronically. You have to send out a photocopy of your ID card, and that's it. And the same goes for a mortgage or a loan, one of those fast loans. So at the end of the day, they will ask you to verify your identity, so to speak, and they will be asking you to send out a copy of your identity card. And this could also be interesting to generate false location traces. So if I leave my ID card to a person and then this person goes from one hotel to another with my ID card, at the end of the day there is a trace uh, that says that I've been traveling, I've been in those hotels. Well, now this is a post from Victor. Victor says that in 2012 he had his ID card stolen, and apparently he has bought many cars and he has asked for many loans. Some more cases. These are recent cases. A guy from Barcelona, his hobby was to steal gym lockers. Once he got the documentation, he used the identity card to ask for a taxpayer statement or social security statement of the person. Then he took all that information and used it to take out loans and credit cards. He was caught. He was charged for all those crimes. Then another person from Madrid, someone steals his identity after him checking in at the hotel. I guess that happened to you. You go to a hotel, they scan your identity card. What happens with that ID card scanned? We just don't know. We just don't know, especially if their computer has been infected. So that was used to open online banking accounts, etc., telephone lines, etc. Another case, a girl had the ID card stolen in 2006, and she was charged with organized crime ring regarding convenience marriages. Of course, she was not related to that at all. Just his ID card has been used for that. Then another guy from Catalonia. Well, he deserved it. He sold his ID card to that person, and then this person sent it out to a Uruguayan guy working from the Napolitan mafia, and they used the ID card of that Spanish person to check in at hotels. The guy was a drug dealer. Then the police went after the person who registered at the hotel, and then this guy ended up in prison for 626 days. So, piece of advice, do not sell your ID card. So let's tell you more about ID card now. This was the first ID card in Spain. In 1824, Ferdinand VII created the police force in Spain, and it was the only authority with the competency to issue this type of official document. The ID card including the following data: age, gender, marital status, occupation, and the place of origin. Then that was followed in 1941. Then the competencies were given to local governance, and then the information on the ID cards was just, depending on the holder of the ID card. The first version of the ID card, let's say version 0.0, a decree was launched in March the 2nd, 1944. The call for tender was 3,000 pesetas. So the requirement was for it to fit into a wallet and for it to have enough space to stamp a fingerprint and a picture. And then the ink should be tamper-proof. And the awardee was this man shown on the screen, okay, Aquilino Riuset. In 1951, the first ID card was issued to Tío Paco. Number 2 was given to Carmen Polo, and number 3 was given to Carmen Franco. And what was the assignment process? So the first people to benefit from it were prisoners and supervised released individuals. as well as the male individuals who frequently change their home address due to personal reasons or to business reasons. And then also to male individuals living in cities with more than 100,000 inhabitants. Zaragoza was the first city, by the way. And in 1961, from numbers from 10 to 99 were reserved for the Spanish royal family. 10 for King Juan Carlos, 11 Queen Sofia, 13 for Elena. She has always been very unlucky. Well, number 13 was removed for superstitious reasons. Okay, I wouldn't mind to have it, if not me, my children. Right from 1962 to 1965, color of it was changed. They also added blood type and marital status. And then the gender information was removed. I just don't know why, but they did it. We move on from 65 to 80. The signature was removed. From 81 to 85. So the coat of arms was more constitutional, and then again the gender was added. From 85 to 91, you may notice that the expiry date extended to 10 years. And they crossed out the blood type and marital status. And then in the 90s, they added a letter at the end of the number. And the first numbers were manually assigned. And that was computerized in 1991. A special department was created to resolve the wrong number issue, that is to say, the overlapping numbers. It was a bit of a trouble there. And now, 1991, 1996, ID card version 1.0, it's smaller, no fingerprint. And then they added an area that can be read automatically with a machine. These are these two lines here. So this is the one that I got. They changed the photograph. Now the photograph was color photograph, and then they added one more line of OCR characters. Then 2000, 2006. So you can see that they have also added this information here on the front side. They also extended the, gender. So instead of writing just an M, they also wrote down M and F and V, M for males. So version 2.0, first electronic ID cards. We all know that works very well with the root pages and admin. So in this case, they added very many physical security elements to prevent cloning. So the chip is the one that shows on the screen, ST19WL34 from STM Microelectronics. So it is divided in 3 areas. First of all, the public zone with the intermediate CA certificates, Diffie-Hellman keys, X509 certificates that can be easily read without any restrictions. I'm not making up anything, I'm just making a summary of it. Then there is a private zone where we have the signature and authentication certificates, and that can only be accessed through a PIN. And then a security zone, only accessible through special spots where you will get access to all the information on the cards. That is to say, as well as the photograph and the signature. So here you may remember that the photograph was color photograph, and now photograph is black and white. Now the characters follow the OCRB standards, and now we have the version 3.0, which is the apocalypse. Again, new physical security elements are introduced. A chip now is on the back panel. I guess that some of you have that one. These ones, they started in 2015. So this is the chip Infinium, and it has the CCEAL5 Plus certification. It is divided into zones. The public zone can be read without restrictions, as well as the security zone, including all the information on the ID cards, as well as the photograph and the signature. This is what it says in the official report, only accessible through special spots. Is there anyone here from the police force? Please update that information, because that's not updated. It is not true. Is my home special spot? Well, my mother says that I'm a special guy, but that's about it. These are all the security elements that have been added to these new ID cards. As you see, very many of them, because they want to prevent cloning. Okay. They have added a number on the front panel. This one here. So the first ID card, the ID card 3.0 Mireia Belmonte. It also has NFC capabilities, and this is what has brought us here today. Oh, by the way, I just want to dismantle some myths. Let us start now. So every year, 6 million new ID cards are issued, and then this number here is not about the number of people who have the same name as yours, but it's just a control digit. And well, if you have a low number on your ID card, that does not mean that you have the number of a person who is dead. ID numbers are unique. By the time the 8-digit numbers will be over, they will just add one more digit, and that would be it. Now, NFC. Does anyone know NFC? Is it that you did not attend the previous project? Well, this is a bidirectional short-range contactless communication technology, allowing two devices to communicate at a distance of 10 centimeters. It is based on RFID standards, works in the 1346 megahertz spectrums, and there are two types of transfer rates. So we are based on the following. Security is based on proximity. I don't know whether you're aware of it. We were here at the Rooties, and we gave a presentation about NFC and credit cards, and we proved that this is not right. Security is not based on proximity. So there are these two standards, the first one defining NFC, and the second one defining the packages that are sent out. So 3.0 version uses this protocol with where T equals CL, and another one where T equals 0. Another myth. IDCA radio frequency. I think it was the minister who came out and said, we are going to monitor people during demonstrations. I will go and say to the minister, look, this is your best success probability. And, well, your success likeliness is very, very low. 1 divided by the population in Spain. Also, different threats that could affect NFC. For instance, eavesdropping, communication can be secure as a solution. Eavesdropping is, well, listening. Okay, someone is there listening. Then data modification, because we are talking about radio frequency. Well, it could be the case that someone would modify, change waves. Raul, you are there. So Raul, a couple of years ago, you gave us very cool demos about that. But that requires significant knowledge about radio frequency. And it is also possible to launch a relay attack. And this is what I did with Pepe a few years ago. Relay attack is about forwarding information, wireless communication. So this is a recommended reading. It is a report on threats of the CCN CERT. So now, going into more detail now. So what is the type of information that I can get from NFC? So this information that I can gain access to is divided in 4 different groups. So for instance, the first group is made up of all that says on the screen: name, family name, nationality, gender, ID number, expiry date, birth date, etc. Then the second group of information of data is the photograph. It is JPEG 2000, but what is interesting here is that there is no metadata. It is good. Not having metadata is good. So therefore, the attacker doesn't know the machine that is being used to issue ID cards. So for instance, if the machine would have said, oh, I'm Philips machine, then the attacker has starting points. Then we have the handwritten signature. There are no metadata here, which is also good. And the last group of data, group 11. All right, and here we have examples. Spain, ID, in our case, Zaragoza, as the place of birth. And other fields that are still null, such as telephone and occupation. Those data could be included in our ID card, but they are not. But perhaps in the future they will be included. How do you access ID card through NFC? Well, basically through 2 standards. One of them being BAC. It is established by ICAO standards. ICAO is about reading of ID cards and establishes regulations for that. And this is included in a document, whose title is Machine Readable Travel Documents. And why did we do all that? Well, this is an initiative of the US, because US wanted all this protocol to be faster. That was done to defend against skimming and eavesdropping attacks. This is a symmetric key device authentication. Both parties identify each other, and then a session key is agreed. Then as an initial key, some parts of MRC data are used. I don't know whether you've been to, whether it happened to you before. For instance, when you travel by plane, they take your passport and they swap it.
They read it and they take certain data from it. So you take the serial number, which is not the ID number itself. It is the support number, I think it is called. Yes, support number. Physical support, I mean. That's 3 alphanumeric characters plus 6 digits. I don't know if there's any logic applied to the sequence. I think there isn't. Birth date, expiry date, in the American format, year, month, day. since we are using symmetric cryptography, the strength of the MRZ-derived password will depend on MRZ itself. We'll do some calculations. It's 11 something. So we can talk about mathematics. You're awake enough, yeah? So at the top we have the bits that we need to cover all possible values. Serial number, we will have 34 and something. Birth date, 15 point something. Expiry date, well, we have different expiry dates in our ID cards in Spain. If you're under 30, your ID is valid for 5 years. If you're above that age, it's 10 years. And if you're above 70, it doesn't have expiry date as such. Here we will have the basic calculations. I use 10 just to use a figure. This could be fine-tuned if we only think about working days and not bank holidays or weekends. Obviously, the birth date is usually published in social media, so you would have 0 bits, because we know about it already. So if you do the calculations, 61 bits, more or less. This is less than the 80 bits that are recommended by both NIST and eCrypt to protect yourself against eavesdropping and other offline attacks, okay? This is not a problem affecting the ID card in Spain only. This is an international standard that was adopted some time ago, but nobody's perfect. It's got its own flaws, and that's it. We need to live with it. So the Germans came along with something. The BSI, the German Office for Standards, came along with a new proposal for a new protocol, PACE, Password Authenticated Connection Establishment Protocol, to defend yourself against the attacks that are possible with the type of ID card we've been talking about. The interesting thing is that this protocol can generate cryptographic keys that are very strong based on a really weak password. Take a look at the steps. I included the steps so you could see them. I'm not going to read them. That weak password is the number we mentioned at the start, which is here on the front, okay? Bottom right. This is a number with 6 digits. Well, funny enough, from those 6 digits, we can go up to something like 2 raised to the power of 128. So it's 2 raised to the power of 128. And you wonder, how much is that? Well, that's a lot. To give you an idea, the distance between the Sun and the nearest star system, Alpha Centauri, is something like 2 raised to the power of 45. It's like going to Alpha Centauri, coming back and going again because you forgot something there. So a huge amount of details. So far, so good. I've told you all the necessary theory to understand what I'm about to explain, which is the security assessment we've done on the ID card in Spain. The first thing we did was wondering about this. Now, DNI or ID card 3.0, how does it behave against a brute force attack? We didn't go into the cryptography. I'm not a mathematician. I'm not a cryptographer. There's excellent people out there, very talented. This can be verified otherwise. So I went for the easy part. So a brute force attack on PACE. Let's go for it. Let's see what happens. We developed an application called, well, DNI brute force. Not too original, I have to say. We used AndroSmex as a code skeleton. This is a piece of code that is used to communicate with the German ID card. By the way, the German ID card and the Spanish ID card use the same chip. The hardware we used was this tablet, an Xperia Z3 from Sony, and we logged the first 500 connection attempts. This is the chart that was obtained in a sequential attack. We use CAN 0, CAN 1, and so on and so forth. On average, the protocol would finish within 1.5 seconds, roughly. So what are the conclusions that we can derive from that chart? There's two things you can infer from that chart. Come on. First of all, an incorrect CAN, well, you only know about that in the last protocol step. In the very last step, when we reach this point, when these are generated, they're exchanged, and a checkup is carried out, that's where we find out that the CAN is incorrect. So in the very last step of that protocol is when you know whether the CAN is correct or incorrect. If I'm the attacker, of course. Is that a good or a bad thing? Well, this is good, because we're not giving any clues to a brute force attacker. They have to wait for at least 1.5 seconds to see whether the CAN is correct or wrong. Tough. But there's another thing we can derive. What happens with this time? The 7th and the 8th grades in primary school in Spain. This is a linear function, yes? There is no defense implemented online against brute force attacks. If I go for it with a brute force attack, it will always behave in the same way. Execution time remains the same regardless of the type of connection, and that is a bad thing. So we thought of an attack scenario like this one. Just imagine that we have an Android device that has been infected, it is compromised, and the device is listening. Whenever it detects an NFC card, obviously it would need to find out that this is an ID card, but it would launch a brute force attack. In the worst case scenario, if there are no interruptions in communication between the mobile phone and the device, it would take it 17 days. We're talking about 1.5 times 2 raised to the power of 6, that's 17 days. We could get someone's identity, steal all the information from an electronic ID card, the photograph, everything, in 17 days, in the worst case scenario. Technically speaking, that means it is possible, but obviously it is quite unlikely. Now, we could be talking about directed attacks, streamlined attacks, but if we're interested in stealing information from someone we're interested in. Okay? In that case, waiting for 17 days wouldn't be too much. But we're assuming that there is no interruption in communication. If I was able to do fingerprinting for the ID card, if I could uniquely identify each and every one of those ID cards, I could do a stop-resume attack. Therefore, it would take me more than 17 days, but it would be feasible, in theory. So how about this? Well, use a function that is related to the time of connection. And what the output will be based on the connection time. Fi equals t when I is less or equal to 5 attempts. Fi equals max when I is under or equal 15 and 15. That would be a chart like this one. In only 50 attempts, you see the response time would go up to 15 seconds or 14 seconds. 15, yes. If you needed 17 days with 1.5 seconds, well, just imagine what happens with 15 seconds. You can forget about it and go home. By the way, those limits, 5 and 15, they're arbitrary numbers. Okay? You can implement whatever. You can use whatever values you want. This, we told the Royal Mint, well, we went to the CCN, the National Cryptography Center. The people over at the Royal Mint said that they were grateful, and for future releases of ID cards 3.0, they will be implementing the small defense mechanism. The second thing that came to our mind was how random is numbers generated by the random generator. Random numbers don't exist, by the way, let me tell you, in case you didn't know. So we said, let's take a look at the random generator. Let me tell you, the chip used by the ID card is an Infineon something with CCEAL5 plus certification, and PRNG, the random number generator, satisfies the requirements of class PTG2, okay, as defined by BSI. What that means is that the chip shall include a physical source of entropy, which is later fed into a software RNG. Apart from that, the output is then processed and checked for errors and statistical deviations or bias. That is done internally, which is a good thing. That's quite reasonable. So we said, okay, let's test it. The data set included 10 to the power of 5 of those random numbers. They're all 16 bytes, so that's a huge number. With these numbers, the first thing we tested was do we have any repeated patterns or any repeated sequence? There was nothing. The probability of collision is of the order of 10 to the power of -3. As test suites, we use those methods that were compatible with the connection, which is relatively short. Right, there's something else on the slide. I don't think you can see it. This part of our work was conducted in collaboration with the University of Valladolid, with Juan Carlos García Escartín. Thank you. We'll be in touch. I'll change the slides so your name can be seen on them. So we use the ENG utility, which measures entropy. I'm showing you the results directly. Entropy is 7.9999 bits per byte. That's almost 8, yes? Optimum compression will be 0%. If it's a random output, a random number cannot be compressed. The size has to be the same, even if you compress it. If it's the same, it's a good random number. And we also used the chi-square distribution, and the results coincide with what we could expect for a random sequence. Okay, other things. We also did NIST tests. Okay, FIPS 142. These are the results. All tests were passed successfully, so it all seems correct. We then did something. This is a visual test with a method called delayed coordinates. Here we plot each one of these points in a certain space. Why do we need to do these things? Well, we're talking about 2 raised to the power of 128. How can you plot that amount of dots? If we found some sort of correlation in the data, something that you're about to see in the next chart, we will see something like a bias. I'm plotting the dots in a certain space. If there was a bias, they will be concentrated in a certain part, or they will be aiming in a certain direction. But this is what we found. This is a perfect shape. Here we have it in 3D. So a perfect shape. And these are the axes, XY, XZ, and YZ. Okay? Not everything is in there because we have a life apart from work. But anyway, the larger the number of dots represented in the picture, the better you can see the shape and the distribution of those dots. As I was saying, the distribution of these points in the phase space is consistent with a uniform random number generator. Now, a little disclaimer. This test obviously will not necessarily show long-term correlations. However, considering the aforementioned experiment results, together with this, our confidence on the pure randomness of the nonces is increased. And now I will need a good-looking lady from the audience. Thank you very much. Let's do a little demo. I'm getting there. Just bear with me. This is the easiest way to get hold of a webcam. So let's go for it. I'll start the application now. I really like all of you, but I'm not showing you my data, okay? I just don't want you to know where my parents live. So I'll start with a number that is quite close to my CAN, okay, so that it doesn't take forever. I've applied censorship because I will be censoring the information, and I'll now use the ID card, okay, in the shadow, so you cannot see the details. And I'll wait for my tablet to connect. You see that tag was found at the bottom, the message. It's playing around, 7, 58, 59, 60. It will stop there. It's recovering everything, right? Everything is done. First name, surname, gender. It has created 2 small files, okay? Rostro and something else. Brute force attack. Well, it's working. Wow. Don't go that fast. Anyway, because I work for a public institution, all of my details are in the internet. So 2 files were created a moment ago. That's my face and the signature. So it was hidden from view anyway, so that you can copy it. Anyway, my face is visible. That's me on my ID card. Thank you very much. So you have the source code if you want to play around. At the bottom, you see the URL. So, thank you, gods. The demo went well. Conclusions. DNIe version 3.30 incorporates an NFC chip. Attack vectors are increased, of course. These are the potential attacks. A new window has opened, which is the NFC. Let me remind you again about the types of attack. Eavesdropping. Is it feasible to do eavesdropping on this ID card? Yes. However, doing eavesdropping doesn't make any difference because the information is encoded. So anyone seeing that information would see nothing, because that PACE protocol works for offline attacks. Data modification, another type of attack. Altering or inserting new information is not possible because of the cryptography, so it wouldn't be recognized, so it wouldn't work. And then relay attacks. We haven't tested them yet. I mean, someone stealing the information to do things somewhere else, as they usually do with the credit cards. Well, that's something we haven't tested, but I would bet this is possible. If someone wants to do this, if someone is interested in investigating about this, go ahead. Please let us know. As a summary of our security assessment, we've seen that the pseudo-random number generator passes all statistical test suites. We've seen that that random distribution fits into a perfect shape. And we've also seen that the PACE protocol is vulnerable because there's no defense against online brute force attacks. There is no defense mechanism in place. Okay? Now, let me tell you that getting to the information takes 17 days with no interruption communication. So, DNIe 3.0 is secure enough. For the time being, there's more pros than cons. It is safe enough or secure enough. There's only that small detail that will be corrected in the future. And that was all from me. If you have any questions, I'll jump the queue. a question you have the right not to answer. Okay? It's this ideology, my question. In Anglo-Saxon countries, the concept of an ID card doesn't exist. People don't have ID cards. If you want, you can have a passport. And if you want to drive, you have the driving license. And that's it. In any case, they would use your social security number, which is not compulsory. So you don't have to identify yourself in any way. Am I right? Yes. Why do we need to identify ourselves in Spain? And do you have an opinion? How about getting rid of the ID to start with? This ideology, my question, okay? Regarding why in Spain we do have ID cards, well, ID cards were around when I was born, anyway. I guess this is because of the times we live in, or the times we were living in. I mean, this was the 40s in the 20th century. I don't know. As regards whether it would be necessary to get rid of ID cards altogether, well, that's a complicated answer. I think it's reasonable to be registered into the system. I mean, having something on you that identifies you, it's good for some things, bad for some other things. But Anglo-Saxon people don't, I mean, people in the Anglo-Saxon world don't have ID cards. Well, I wouldn't like it to be exactly the same in Spain. There are some things I like, some things I don't like. Let me tell you what I'm asking. When I go to a hotel, I give them my ID card, they store my data, and everyone knows I'm there. Well, not exactly like that. Well, technically, before we move on, unless I'm wrong, hotels have the obligation to tell the police who checks into the hotel. So you do your check-in and you're a terrorist. Do you go to a hotel and you don't use your ID card? But if you were silly enough to do it, the hotel would tell the police, well, this guy did check in, so the police would come along, or the civil guard would come along and arrest you. For people with search warrants, can I quote something? The Spanish Constitution, where it says that I have a certain right to privacy. But when I go to a hotel, I don't have that right, and it's not a judge that decides that. I insist, there is a lot of ideology in my question. I mean, doing check-in in hotels, that makes me really nervous. I'm with you. And it makes me even more nervous. In China, I was there recently. They scanned my passport, and they didn't just scan the first page. If you want to scan it, fine. Scan it. Otherwise, you cannot stay in the hotel. But I was even more nervous to see that they had scanned my visa for the States. That really made me nervous. I said, why did you scan the visa? Well, if you made a mistake, well, give me the piece of paper. They started talking in Chinese, and since I cannot understand Chinese, well, I lost. They scanned the main page and the visa. I'm not saying they're going to do wicked things with it, but I don't like it. And excessive control is always a bad thing. And whoever argues that having an excessive control because there are terrorists and bad people around, they're a tyrant. I don't want to pester Ricardo about his talk. Any questions, any comments?
Hola.
Good morning. Thank you very much for your presentation. Where are you? Okay. Please stand up. I'd like to qualify two things that you mentioned. One is about constant time during the brute force attack. Some people may misinterpret what you just mentioned, because that time should be constant time, otherwise we wouldn't have timing attacks. Well, yes, that's the way it is. Well, and perhaps I'm just saying that because someone may misinterpret it. It is just a small time, it is not constant time. Yes, you are right. Well, it being constant is a good thing. As you say, technically speaking, we are talking about timing attacks. Yes, timing attacks. That's what it is, technically speaking. And then regarding the information that you get with that attack, We should also mention or point out that in the attack you don't get the private key of the certificate nor the fingerprint. Oh yes, of course, this is all the information that you get with the attack. This is enough information for a person. For instance, if I want to steal someone's identity, if I want to make a ID card 2.0 or 1.0, if that were to be the case, that is enough information for that. Well, but that information is not that confidential, so to speak. Well, yes, you might be right. All right, thank you very much to you. Well, the main problem regarding data confidentiality, well, I mentioned that very quickly before. Well, here there are people working in different ministries in the public administration. Those of us who are working on the public services, we are registered in the official gazette. Then you can see name, surname, and identity card number. And it is not the first time that people use those details to subscribe to a telephone line, and then they leave a debt. And imagine that you are a member of that company, you are a customer, and then you want to switch companies, and they say, no, you have to pay your debt before you switch company. So this is as much as confidentiality goes. So I would like public administrations to fix that somehow. All right. Any other questions? Very interesting, your presentation. I didn't know much about ID cards. And my comment is a curiosity, rather. I've seen that the photograph is black and white, whereas the card is colored. Is there any reason for that? Well, I just don't know. Well, apparently, facial recognition, in terms of facial recognition, many experts say that a black and white photograph against a white background is best in terms of, is best for that. I just don't know whether that is correct or not. Next question. Roman, I believe that once the article is implemented, it will be just impossible to remove it. It will disrupt very many things, so I don't know whether it is worthwhile to go into that debate or not. And then Ricardo, well, the times that you showed us are those with, well, there were Android times. What happens if we just download a specific hardware for that, and then we can shave off those specific, those peaks? Well, when I try to run the demo at home, so the time is second, 1.2 seconds, 1.1 seconds. That varies a lot depending on the device. So on this tablet, 2 months ago, time was 2 seconds. Now has gone down to 1 second. I just don't know why. Well, the thing is that the app hasn't changed as much to reduce the time as much. So the answer would be, depends very much on the hardware. And if we use a specific hardware, yes, of course. But if you are going to set up a specific hardware for that, well, I don't know. Well, the idea is to infect an Android and then to steal identities from there. You will need a chip, NFC chip, to use it in something that the user has. But if you want to carry out an attack with improved capabilities, yes. Well, for instance, you could use Copacabana, for instance, to break back just in seconds. You can also do that. Well, I thought we were in an event where people question everything. This looks like Disneyland. Thank you very much, Ricardo. I don't know whether you mentioned that or not. So regarding overwriting on ID card, have you tested anything? Same as you access to remote data? No, I don't think, we haven't tested it, but I hope you cannot do it. No, I have not tried it. I don't know whether the PACE protocol has some packages to allow overriding, but I hope not. I don't think so. Well, some protocols inject a balance on your cards to buy your underground ticket. No, that's a different type of card. You should have came to the Rooted a few years ago when we came over here and we gave a presentation on Mayfair. That's a different type of card. Data signed, I mean the signature and the photograph. No, we thought they were signed. Oh, no, they are JPEG 2000 plain. That's not a suggestion. Not metadata. I mean signed by the actual police. Yes, I know what you mean. It would be very interesting to have them signed, to add reliability, and to make them more tamper-proof. Politics. I just don't want to have my identity stolen the way they do it in the US. That's a very good answer. So he also comes from Aragon. So, Alfonso now. I'd like to make a comment or drawing on what another person said over there about timing attacks. These are two different things. The way ID card works to decode and decode, and then you adding time to it. So the ID card works as it should work. Time should be constant to avoid attacks, but you can introduce a relay to the connection. Yes, that's the idea. That's about it. You introduce a relay so that you can carry out your attack. Yes, same as you can inject a glitch to a chip to create a fault so that it takes longer to answer, as Alfonso says. Response has to be given on the right time, on the very same time. But the idea is delaying response times. So the last question. Can you opt for not having this type of ID cards, or perhaps can you disable it? You know, I was thinking about those credit cards that you can punch. So do not answer, Ricardo. Do not answer that. So we've done it, okay? Punching credit cards, it's a crime. Oh no, the ID card would be a crime because that is a public title. So as he said before, or drawing on what he said before, data are signed. But to access data, there is another protocol on top of PACE. So that protocol is used also for passports. So you can interact with the ID card in terms of data fingerprint. This is a stronger protocol, and it comes with a digital certificate. And as far as I read, the ICA or standards, the signs, they are signs. I read about AIC, so the signature does not, the data groups, well, in data groups, all the information is encoded. Yes, but they are also signed. So, but I guess that you need higher authentication to that of PACE. PACE allows you to access data that you access when you read the ID card. Okay. So wouldn't it be interesting to have someone from the Mint or from the issuing companies or from the police forces to give a presentation in that regard? Yes, it would be very interesting if they were to do it. I am in favor of identity cards as a means of authentication. There is a huge potential there. So the solution to prevent the attacks that he mentioned, that is to say, well, we CB7, our DNA number is published at the official Gazette. So it would be very good so that we are asked for data other than entering your date of birth or ID number just to authenticate yourself. All right, so okay, we stop here and we can discuss that generally. All right, thank you very much. Thank you very much, Ricardo.
Bueno, gracias a todos.